Hello and welcome to another episode from Spiral Physics Education. In this episode we're going to be looking at what forces can do, different types of forces, concentrating on forces that act at a distance and forces that act while in contact, the difference between weight and mass. We're also going to be looking at calculating weight, and we're going to be covering that with some examples as well. So let's have a look at what forces can do. And really forces can be simplified by placing them into one of two categories, and that's there can be either a push or a pull. And when these forces individually or in pairs or in more than just pairs, they can do various things to objects. So they can change the object's speed, they can change the direction that that object is moving in, and they can change its shape and they can change its size. And it's worth remembering what forces can do to objects, so make sure you know that list. So there are some different forces that you need to be aware of for your exams, and you need to know that some of them act at a distance, i.e. they don't need to be in contact, and some need to be in contact. So we're going to be looking at a few examples of ones that act at a distance. And the most common one in physics are gravitational forces. And the thing to realise about gravitational forces is that when an object has mass, it produces something called a gravitational field around it. And that gravitational field is larger should that object have a larger mass. So for instance, the Earth has a much larger mass than you do, therefore the Earth's gravitational field around it is much larger than yours. And the thing to remember there is that gravitational fields exert forces on objects inside that field that have mass. So for instance, you have a mass and you are present in the Earth's gravitational field, therefore the Earth exerts a gravitational force on you. And that these don't need to be in contact with each other, so you get gravitational forces acting on you if you're in the air as well as on the ground, but it's not the contact of the ground that causes that gravitational force to be exerted on you. So another force that acts at a distance are electrostatic forces, and these are caused by objects that have charge. So whether they're positive or negative, it doesn't matter that they produce this electrostatic force. And the objects that have a charge produce an electrostatic or an electric field around them, just like objects with mass produce a gravitational field around them. And if an object has a larger charge, then it will have a larger electrostatic field around it, and therefore it can exert larger electrostatic forces. And that this electrostatic field will exert forces on objects within that field if those objects have charge. So for instance, if you had an electric field produced by a positive or a negative charge, and you place an object with charge inside that, you might get attraction or repulsion taking place. And then again, these forces don't need to be in contact, they can act at a distance. So the last force that acts at a distance that you need to know about are magnetic forces. And quite simply, magnetic forces are produced by magnetic fields, and magnetic fields are produced by magnets. That's all you need to know about that. And that these magnetic fields exert forces on magnetic objects within that magnetic field. Common materials are iron, nickel and cobalt that would have forces exerted on them. And the thing to remember there is that the greater the magnetic field, the greater the magnetic forces can be exerted on them, and that they don't need to be in contact, that they can act at a distance. So some forces do need to be in contact with each other, or the objects need to be in contact to experience the forces. And the first one that we're going to look at is friction. And friction occurs when two or more objects rub past each other, so they've got to be in physical contact with each other. And another thing to realise about friction is that friction always acts in the opposite direction to the object in motion. So if you're running in this direction, friction will act in the opposite direction. Another thing to remember about friction is that the result of friction, it causes heating, and it causes a thermal transfer of energy to the surroundings, a dissipation of thermal energy. And that dissipation of thermal energy can be reduced by lubricating the objects that are in contact with each other. But remember that those objects must be in contact with each other. So another contact force that you need to be aware of is a normal contact force, or sometimes referred to as a reaction force, a normal reaction. And when two objects are in contact with each other, normally when we talk about reaction forces, when people or objects are either sitting or in contact with a surface. So standing on the ground, sitting on a chair, those sorts of examples. And the direction of this normal contact force is very important, and that is that it's always at 90 degrees to the surface that the object is in contact with. So I'm going to show you a couple of examples to make sure that you understand what that means. So here we've got the ground, and here we have a person standing on the ground. They are in contact with the ground. So the normal contact force is at right angles to the ground. Now, just to make sure that you understand that, let's change the shape, direction, orientation of the ground a little bit so they're on the hill. And this person is leaning a little bit but still standing on the ground. That means the normal contact force is still at right angles to the ground. Okay, so let's have a little look about weight and gravity. It's an opportunity to discuss about the vocabulary used with weight and gravity. So first of all, weight is a force, where gravity is not a force. Gravity is the short term for gravitational field. So we can't really use gravity and weight to mean the same thing. I'll give you an example question for this. Let's say we're in an exam and you get this basic question. I've got a fly going around here at the moment. So what force causes objects to fall to the ground? So I've seen in lots of in many students' answers that they would write gravity, and sometimes that's given, but it depends on the examiner or the examination board whether it's acceptable. But technically, it's wrong. That gravity is not a force, so we can't answer that question, what force causes it, with something that isn't a force. However, force due to gravity, well, that would be a much better answer. And even, well, not even better, but just as correct, weight. Weight is the force due to gravity. So try and not use the word gravity to describe a force, but instead use the force due to gravity. And obviously weight would be correct. So let's have a look at how you can calculate weight then. Very, very common questions in exams. So on Earth we have a gravity of, it's actually just under 10, but for GCSE we say it's 10 newtons per kilogram. And what that means that for every kilogram of mass there is a force of 10 newtons produced on it, or a gravitational force of 10 newtons is exerted on that kilogram. So 1 kilogram will produce a 10 Newton force. So mathematically, when we look at that, it just means that weight equals mass times gravity, or W equals mg. But one thing that we've got to be very, very careful of, and I've seen students throw so many unnecessary marks away, is that mass must be in kilograms. And exam boards love giving you mass in grams. So do check the units. Gravity is in newtons per kilogram, and if the mass is in kilograms and gravity is in newton per kilograms, then your weight will be in newtons. So let's have a look at an example. So here we have a person that's got a mass of 55 kilograms, and we're going to calculate their weight. And we're told, you always get told, that on Earth gravity is going to be 10 newtons per kilogram. So we always write the equation down. And we can first of all check that the mass is in the right unit. So if we look at the question, 55 kilograms, we're not being confused here about the units. The units are okay. So we can just substitute in 55 times 10. We've got a weight of 550, but don't forget the units. Okay, you'll lose a mark sometimes anyway if you forget to put the units in. Let's have a look at another example then. So what is the weight of a 50 gram slotted mass? Okay, this is where it gets a little bit sneaky. We'll still get told that gravity is 10 newtons per kilogram on Earth, but the exam board is being sneaky here because they've shoved in a mass in grams. Most students here will just multiply 50 by 10 and won't get full marks available. So the first thing that you need to do is convert those grams into kilograms. So we divide by 1,000 and 50 grams then becomes 0.05 kilograms. So now the units are correct. Now we can quote the equation and now we can substitute in 0.05 times 10. We get an answer for our weight of 0.5 and of course newtons to complete the answer. Let's have a look at another example then. So when NASA landed on the moon, the Eagle lander that they used had a mass of 4,300 kilograms. And we've been told here that the moon's gravity is a sixth of that on the Earth. And of course, the Earth has a gravitational pull of 10 newtons per kilogram. So what we're going to do is calculate the weight of the lander on the moon, and specifically we've got to answer to two significant figures. So we've got to be a little bit careful there how we leave our final answer. And of course we get told or reminded that gravity on Earth is 10 newtons per kilogram. So the first thing we need to do is work out the value of gravity on the moon, and we're told that it's a sixth of that on Earth, so it's a sixth of 10, which is going to be 0.67 newtons per kilogram. So that's worth a mark. Then we can quote our equation, and now we can substitute in, just checking that the mass is in kilograms, which it is, and multiply that out, 7,181. But that's not the final answer. If we check out, it says that to two significant figures. So to two significant figures, it's 7,200, and don't forget the units. So I hope you found this episode on forces, mass and weight useful. Don't forget to subscribe to the channel to watch other videos that will help you improve your understanding of physics and hopefully improve your grade in time for the exams. I'll see you next time on Spiral Physics Education.